Welcome to Practical Statistics for Nursing using SPSS. This video shows how to process the ANOVA repeated measures test. You can watch the entire video or use the time slider to navigate directly to any time point. The ANOVA repeated measures test is quite similar to the paired t-test. Before proceeding, it's recommended that you first view the video CH09 paired t-test.mp4. In terms of setup, the ANOVA repeated measure test and the paired t-test are quite similar. Whereas the paired t-test processes data from one group over 2 time points, pre-test and post-test, the ANOVA repeated measure statistic can process data from 3 or more time points. The ANOVA repeated measures test will compare the means from time 1 to time 2, time 2 to time 3, and finally it'll compare the beginning to the end, time 1 to time 3. The ANOVA repeated measures test has one pre-test criteria, Mauchly's test of scarcity. We'll check for this when we run the ANOVA repeated measures test. This example uses the dataset CH10 example 01 ANOVA repeated measures.sav. This dataset contains 3 variables. Initials is a string variable that contains the initials of each participant. Time 1 is a continuous variable containing the mean number of cigarettes that each participant smoked per day prior to treatment. Time 2 is the mean smoking rate at week 2, a week after the intervention started. And time 3 is the mean smoking rate at week 3. To run the ANOVA repeated measures test, click on Analyze, General Linear Model, Repeated Measures. Erase Factor 1 and type in Time. For number of levels, enter 3. Meaning that we'll be comparing measurements taken at 3 time points. Click Add, then click Define. On the Repeated Measures menu, move the variables Time 1, Time 2, and Time 3 to within Subject's variable Time. Be sure to keep these in order. Click on Options, move Time to Display Means For, check Compare Main Effects, and check Descriptive Statistics. Click Continue. On the Repeated Measures menu, click Plots, move Time to the horizontal axis, and click Add. Click Continue, click OK, and it'll process. We'll begin by assessing the pretest criteria, Mauchly's test of scarcity. We see that the p-value is 0.066. Since this is greater than 0.05, this indicates that there are no statistically significant differences between the variances of the data gathered at the 3 time points. Hence, this pretest criterion is satisfied. Next, inspect the tests of within subjects effects table, focusing on the time scarcity assumed row. Since the p-value of 0.015 is less than 0.05, this indicates that at least one of the time points is statistically significantly different from another. To determine which time point outperformed which, we look to the pairwise comparisons table. This table reads like the standard ANOVA post-hoc table. The first pair compares time 1 to time 2. Since the p-value of 0.010 is less than 0.05, this indicates that there is a statistically significant difference between these 2 time points. The second pair compares time 2 to time 3. Since the p-value of 0.512 is greater than 0.05, this indicates that there is no statistically significant difference between these 2 time points. The final pair compares the beginning to the end, time 1 to time 3. Since the p-value of 0.013 is less than 0.05, This indicates that there is a statistically significant difference between these two time points. The estimates table shows the means for each of the 3 weeks. These figures will be useful when documenting the results. The mean smoking rates over these 3 time points can be seen graphically on the chart. This concludes this video.